Welcome to the Discovery of Surge Arresters e-learning module. It should take you about 30 minutes to complete. Click the Next button to continue.
At the end of this module, you will be capable of achieving the following 4 objectives. Get to know overvoltage and the harmful effects. Know how to protect against overvoltage. Adhere to Schneider Electric's safety approach. And lastly, include surge arresters in systems and solutions. In your opinion, is overvoltage in electrical networks due only to natural phenomena such as lightning?
Congratulations! You're off to a good start. Click the green triangle in the bubble to continue.
There are 2 possible causes of overvoltage in electrical networks. Natural causes of atmospheric origin, such as lightning, for example, or industrial causes related to the operation of equipment. Networks are subjected to 2 types of overvoltage: transient overvoltage and temporary overvoltage at power frequency. Transient overvoltage is when a voltage surge is superimposed on the nominal voltage of the network. This is an ultra-fast transient phenomenon measured in kilovolts per microsecond. This type of overvoltage generates energy, which is injected into the network, causing premature aging of the equipment connected, the installation, and even destroying equipment if it is a high-energy phenomenon. When surges are of atmospheric origin, the maximum voltage level can reach 20 times the nominal voltage of the network, such as when lightning strikes an overhead line. Click each plus to understand how atmospheric overvoltage occurs. When transient overvoltage is caused by the switching of equipment, the voltage surges are not more than 5 times the nominal voltage. When this is the case, less energy is run off than with atmospheric overvoltage, but if the surges are frequent, they can cause premature aging of equipment. Switching surges are phenomena caused by the starting or interruption of high-power electrical equipment. Temporary overvoltage occurs when there is a rise in network voltage at power frequency, which can last up to several seconds. It can be caused by phase or exposed conductive parts, or phase or earth insulation faults on isolated neutral systems, or rupture of the neutral conductor. When this happens, single-phase equipment is supplied with 400 volts instead of 230. The amplitude could be up to 1.7 times the nominal phase-to-neutral voltage. There may be other causes for a rise in network voltage, such as the breakage of a medium-voltage cable, which falls on a low-voltage line. Overvoltage can spread through both the power supply system and the earthing system, destroying the most sensitive electrical equipment. Here are a few examples of the consequences of atmospheric overvoltage. Click the photos to enlarge them. Know how to protect against overvoltage. Not all devices in electrical installations have the same robustness when it comes to overvoltage. According to the IEC standards, the electric shock resistance of each device is classified in 4 categories with 4 levels of voltage, indicated here. In your opinion, To which voltage category do the following loads belong? Click and drag each load into the category you think is right. Then click the Confirm button.
Congratulations! Good for you!
The most fragile devices are classified in Category 1. They are the ones with the lowest tolerance level. This category includes devices containing a majority of electronics, such as computers, TVs, and stereos. Category 2 includes all portable power devices, such as drills and large household appliances, such as washing machines. Category 3 includes all industrial equipment, such as motor, process control devices, and power distribution units. Category 4, with a very high tolerance level, 6 kilovolts, is used for distribution circuit breakers, energy meters, and measuring instruments. In your opinion, to which voltage category does the following item belong? Move each item into its category.
Congratulations! Good for you!
The installation of surge arresters in electrical switchboards and panels is the solution for protecting against transient overvoltage. They limit the overvoltage to a level that is compatible with the impulse voltage resistance of the electrical equipment to be protected.
So, how do surge arresters operate? A surge arrestor should be considered as a protection device that behaves like impedance that varies according to the voltage across its terminals. When there is no lightning occurring, the surge arrestor does not change the operation of the installation to which it is connected. It is seen as an open circuit by the rest of the installation. However, when overvoltage occurs, the voltage across its terminals suddenly increases and considerably reduces impedance. The surge arrestor then turns on. The surge arrestor plays two roles when this occurs. It runs the overcurrent into the earth without letting it go through the loads downstream, and it limits the transient overvoltage to a level that can be tolerated by the installation and the loads. This value is referred to as the protection level. In this example of an installation without a surge arrestor, the overvoltage wave reached 4 kilovolts, which is more than the connected equipment can withstand. Consequences: the equipment is not protected and is liable to be damaged. With a surge arrestor, the initial 4 kilovolt wave is limited, in this example, to a protection level up of 1.5 kilovolts. Consequences: the equipment is protected correctly and continues to operate without any problems.
Protection level up is the voltage that characterizes the protection performance of a surge arrestor when impulse current in goes through it. To guarantee load protection against overvoltage, the protection level up of the surge arrestor must be less than the impulse voltage UW of the loads to be protected. For protection against transient overvoltage, a surge arrestor must be installed as far upstream as possible from the low-voltage electrical installation. This is in order to divert overcurrent to the earth and thereby prevent it from spreading downstream of the installation. However, people are often unaware that the protection installed at the incoming point is not always sufficient to protect sensitive loads, especially when they are at a distance. This is why fine protection is installed when the distance between the incoming protection device and the equipment to be protected is more than 10 meters. There is suitable protection for each situation with 3 possible types of surge arresters. For incoming protection, Type 1 and 2 surge arresters are used. Type 2 surge arresters should be used in general cases. Type 1 surge arresters are only used when there is a lightning rod on the building. And Type 3 fine protection surge arresters are used in addition if there is sensitive equipment more than 10 meters from the incoming protection. Click the buttons to find out more about each type of surge arrestor. Select the right type of surge arrestor, T1, T2, or T3, for each of the 4 situations.
Congratulations! You have installed the right type of surge arrestor. Electrical installations in buildings are very widespread, and the cables may be several hundreds of meters long. In normal operation, the voltage is more or less the same at all points of the installation. When transient overvoltage occurs, the edge of the overvoltage spreads throughout the installation, creating wave reflection problems. A good image of the total reflection phenomenon is a wave coming up against a wall, representing a voltage wave. The height of the wave represents the amplitude of the voltage. The wave crashes against the wall, doubles in height, and is reflected back in the opposite direction. As a result, for cables longer than 10 meters, the voltage may double. To protect against this reflection phenomenon, a Type 3 fine protection surge arrestor will lower the voltage to a level that is compatible with the equipment's UW.
The complete installation protection system includes one or more surge arresters according to the configuration of the building, as well as an equipotential bonding system comprising metallic meshing of exposed conductive parts and conductive components. In this situation, where do you think the surge arresters with the greatest runoff capability are situated?
A little more effort and you'll get it. Congratulations! Good for you!
In this situation, select what you think are the most appropriate locations in which to install surge arresters.
Congratulations! Yes, surge arresters may be installed in each of these locations. Congratulations! Yes, surge arresters may be installed in each of these locations.
We're now going to help you understand Schneider Electric's safety approach. In your opinion, are these phenomena related to normal end of life by aging or premature end of life? Match each phenomenon with one of the 2 possibilities.
Congratulations! You have selected the right answers. Let's take a closer look at the issue. Surge arresters include an active part which absorbs the energy of the overvoltage and a thermal fuse capable of isolating the active part from the electrical network. The running off of numerous surges over the years causes component wear. An ultimate event such as a stroke of lightning then causes temperature buildup, resulting in melting of the internal fuse. The integrated thermal protection isolates the surge arrestor from the rest of the installation. An operating indicator, which is white when the surge arrestor is in operation, turns red at the end of life, indicating that the surge arrestor must be replaced, since the installation is no longer protected against overvoltage. Certain phenomena can short-circuit the surge arrestor. Phase or neutral inversion, or rupture of the neutral, or a violent stroke of lightning that exceeds the surge arrestor's runoff capability. In all of these situations, the integrated thermal protection does not have time to react. The surge arrestor must therefore be protected by an upstream protective circuit breaker to avoid the damaging impact on the switchboard or installation.
If surge arresters are chosen correctly, they have the same service life as other electrical installation components, such as circuit breakers, for example. However, certain events can damage them and mean that they have to be replaced prematurely. Select what you think causes the end of life of surge arresters.
Congratulations! You've picked the right answers.
This circuit breaker, also called a disconnector, can perform all of the functions required for the installation of a surge arrestor, namely, disconnection of the surge arrestor in the event of a short circuit, no nuisance tripping, withstand 20 shocks at N. Whatever their end of life, by aging or by short-circuiting, surge arresters must be isolated from the rest of the installation in order to be replaced. Disconnectors must be fully coordinated with surge arresters. They are sized according to two constraints: lightning current withstand and short circuit current withstand. A poor choice of disconnector or poor coordination between the two devices can be hazardous. In this module, you may discover the coordination table for the different Schneider electric range surge arresters and disconnection circuit breakers. Click the two constraints to review the animation sequence. Our safety approach consists of always associating a protective circuit breaker with a surge arrestor. There are two possibilities in the Schneider electric product range for the choice of the circuit breaker or surge arrestor combination. Choose a surge arrestor without disconnector and associate the coordinated protection separately according to the manufacturer's recommendations. Or choose a surge arrestor with integrated disconnector. At Schneider Electric, it's easy to distinguish between the different types of surge arresters proposed. The iQuick product designation means that the protection and the surge arrestor are integrated in a single device. Coordination between the two devices is optimized. The choice of the product is quicker, and the risks of error are limited. For optimal efficiency, a surge arrestor must be correctly installed. With iQuick products, installation is simplified, and implementation is error-free. The lengths of cables connecting to panels are optimized and favor surge arrestor efficiency. There are two sorts of surge arresters. Surge arresters with plug-in cartridges. The cartridges may be replaced by a quick maneuver to facilitate operating and maintenance operations. The plug-in range is distinguished by its designation, IPRD or PRD1, or by the version with integrated circuit breaker, iQuick PRD.
fixed surge arresters available with the designation IPF, IPRF1, PRF1 Master, or the version with integrated circuit breaker iQuick PF. Here is an overview of Schneider Electric's low-voltage surge arrestor range. There is also a range available for communications networks and another for DC networks, used particularly in photovoltaic installations. Click the photos to enlarge them. A three-step approach is used for protecting the electrical installations of buildings. First, collect information on the electrical installation, its environment, and the type of electrical equipment used. Choose appropriate protection using a choice of methods, simplified or comprehensive depending on the case. The solution implementation step is important. To find out more about this part, refer to the training module on the installation of surge arresters. In your opinion, which is the approach used to collect information on the electrical installation and its environment? Select the right answers.
Congratulations! Good for you!
Lightning protection should be addressed globally. National regulations, or even some insurance companies, sometimes require that installation designers carry out a detailed lightning risk analysis, according to the method given in the IEC 62305-2 standard. This is the case in France, for example, for sensitive buildings, hospitals, large industrial sites, and data centers. If no regulations are applicable, an efficient protection device may be chosen by two simple methods available in the Schneider Electric offer. The simplified method, described a bit further on which may be used to make a choice, even without a computer, and the use of a Schneider Electric selection software tool, the link to which is proposed further on. You may use the simplified method proposed by Schneider Electric when you do not have a computer available or if you simply need to install a surge arrestor in a simple installation. How does this method work? Use the table as follows. Does the building to be protected have a lightning rod? If it does, a Type 1 surge arrestor should be installed, completed in all cases by a Type 2 surge arrestor at the incoming point of the installation. Note that if a building within 50 meters is equipped with a lightning rod, Type 1 is chosen as well. To find the appropriate Type 1, examine the earthing system. According to the results of the IEC 62305-2 risk assessment analysis, two levels of IMP may be required, 12.5 kiloamps or 25 kiloamps. If there is no lightning rod, only a Type 2 should be installed, and chosen according to the estimated level of risk. Then, assess the distance between the surge arrestor and the equipment to be protected. We now know that when the distance is more than 10 meters, an additional Type 3 surge arrestor should be installed near the equipment. Click the plus marks for more explanations. The panorama shows us which surge arrestor and which circuit breaker to choose, according to two criteria. estimated risk of lightning according to the geographic location of the building to be protected, and short circuit value in each surge arrestor location. All that's left is to choose between an iQuick version and a conventional version. If this method does not enable you to easily find the appropriate product, you may use the selection software offered by Schneider Electric. Click the link and don't hesitate to record it in your favorites. Surge arresters in a global offer. Schneider Electric is a major player in the area of overvoltage protection. It is the world's electrical distribution specialist, and through its products, it can guarantee comprehensive installation protection. Protection against permanent faults, such as short circuits, overloads, and earth faults, is used to protect installations by circuit breaker functions and protect people by residual current device functions. Protection against transient faults, such as overvoltage caused by lightning, among other things, is used to protect sensitive equipment by surge arrestor functions. You will have understood by now that in low-voltage installations, surge arresters are essential in order to provide comprehensive protection. This is the end of the module. You are now capable of identifying the different types of surge arresters and of taking measures to protect electrical networks from overvoltage. You may now take the second module. Thank you for your attention.